Hey guys, today we're looking at 8.3's notes, which is all about graphing quadratics in standard form. Now, in the last section, we talked about graphing just from a regular standard graph, but this is actually what we would consider a standard form. So if you remember, standard form for polynomials was always in decreasing exponent order. For a standard form for a quadratic is also in that form. In this one, we'll have our first term is going to be our x squared term, which has a coefficient of a. Our x term in the middle has a coefficient of b, and then our constant, which is always our last term, is going to be c. So we'll designate each of those three different letters as just being the numbers that are in my equation. A being what's attached to my x squared term, b being attached to my x term, and c being the number that's all by itself. Now my a value in this case is my leading coefficient. That still tells me how I adjust that 135 shortcut like we did in 8.2. Like we did in the previous section. It's still going to tell us whether it's a reflection, whether it's positive or negative, and that's going to tell us whether there's a stretch or a shrink. But again, the most important thing, once we know where my vertex happens, we're just going to multiply my a value times 135 to give me that shortcut for how we graph them. In my equation, my c value, my constant, is always my y-intercept, because we know a y-intercept is when x is 0. Right, my x value, I'm not moving left or right at all. So if I let my x value be 0, all of the other terms go away except for c. So my c value in my equation is always my y-intercept. Now the most important thing that we need, obviously we need to find that vertex and need to know where that happens before we can graph the rest of it. So we need to be able to figure out where that is. Now in standard form, it's quite a bit more difficult because we have a formula that gives us what the axis of symmetry is. It tells us what the AOS is. We have this formula here that's just negative b over 2a. So we take the opposite of my middle term divided by 2 times my first term for those two numbers. And that gives me my AOS. Now remember that AOS is that vertical line in my graph that my vertex is on. So what we'll need to do, once we know where the AOS is, and we can plot that, we need to plug that in to my equation for x to solve for my y value. So it is a little bit more of an involved process to find my vertex, but then once I have that vertex, it's just like we did in the previous section with just using my 135 shortcut. So for box number 2, let's focus first on just applying that formula, figuring out what my AOS is, and then using that to figure out what my vertex is for a particular equation. So for box 2, we're looking at the equation f of x equals 2x squared plus 8x minus 1. So in this case, my a is 2, my b is 8, my c would be negative 1. For part A, that they're asking us to find, is the AOS, the axis of symmetry. And remember our formula, which you'll have this on a cheat sheet for you when you get to the quiz of the test this chapter. Negative b over 2a is my formula for finding that AOS, finding the axis of symmetry for my particular equation. So in this case, if I just substitute in there, negative 8 over 2 times 2 gives me negative 8 over 4. So negative 2 is my AOS. My axis of symmetry happens at negative 2. And because my axis of symmetry is always the x value for my vertex, for part B, to find my vertex, I'm just going to take that x value of negative 2 and plug it into my equation. So if I can go ahead and do that, I'm going to find my y value, which we know is the same thing as f of x. Don't let yourself get thrown off by the f of x being there and having it being function notation instead of in regular xy notation. But we're just plugging it in, negative 2 in there for my x value. So I'm just plugging in negative 2 in for my 2 x values in my original equation that I'm given, so I know what the y value is for that vertex. So just make sure you guys are being careful with order of operations. We should be squaring stuff first before we multiply. So in this case, 2 times 4. So if I just do my exponents first, right, negative 2 squared is negative 2 times 2, which is 4. Be careful on that. When you square a negative, it makes it positive. So 8 minus 16 minus 1 gives me negative 9. for my AOS. Or sorry, for my y value. Right, y, this is all y all the way down. 8 minus 16 is negative 8, minus 1 is negative 9. So that tells me my vertex for that point, or for that equation, is negative 2 comma negative 9. And that is my vertex for box number 2. Okay. For box 3, we're going to go ahead and graph the function. So we're going to have to start by doing the same thing. I need to know what my AOS and my vertex is in order to graph them. But then from there, I could just use my 135 shortcut on the equation to be able to continue graphing it. So first and foremost, I'm going to go ahead and label A, B, and C. So my A value is 2. My B value is negative 4. My C value is negative 6. So if my formula for my AOS is negative B over 2A, that tells me negative 4 over 2 times my A value of 2, which would be a 4 over a 4, so positive 1 is my AOS. And if you want to, because we're graphing this, we can just kind of do stuff as we figure it out. That tells me right there on my graph, positive 1 is my AOS. So that's my vertical line that my vertex can be somewhere along that line. I still need to plug in 1 into my original equation to figure out what my y value is for my vertex. So 1 squared minus 4 times 1 minus 6. Well, 1 squared is just 1, times 2 is 2. 4 times 1 is 4. So 2 minus 4 would be negative 2, minus 6 would be negative 8. So that tells me my vertex is 1 comma negative 8. So right there is my vertex. So from here, I can go ahead and use that 135 shortcut we learned in the last section. But here, because I have an A value of 2, right, this A value here is positive 2, instead of my 135 shortcut, I'm going to double those numbers. So my 135 have to get doubled. So that gives me 2, 6, and 10, because we're doubling those because our A value is 2. We're multiplying it by 2. So from my vertex, which is down there at negative 8, we're going to go up 2 over 1, up 1, 2, 3, 4, 5, 6 over 1, and then up 10 over 1, which is all the way up there. Which that last one you don't necessarily need to have in there, because remember, for our for our parabolas, when we're graphing a quadratic, you need 5 points. So you need the vertex, 2 on the left, 2 on the right. Here we did more than that, which is fine, as long as you have at least 5. So we can go ahead now and just connect those dots. It's going to be pretty steep. Do the best you can, make it curved. But obviously mine's a little pointed at the vertex, and that's okay. As long as you try and do your best to go through them and make them curved, then we're good to go. So the other reassuring thing here that we talked about back up in box 1, this C value is my y-intercept at negative 6, and we can see from my graph that my y-intercept does happen at negative 6. So that tells us we're probably good. So that would be how I would graph those in standard form. Again, the only thing that's different is this first stuff up top, where we have to do a little bit of formula work to be able to figure out where my vertex happens. Once I have that vertex, it's just like we did in the previous section, just that 135 shortcut, adjusted however we need to. All right, last but not least, box 4. We're doing some modeling with quadratics. So in this one, we've got a group of friends that are launching water balloons. The function f of t equals negative 16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it's launched. So that equation gives us the path that the first water balloon follows. The height of the second water balloon, t seconds after it's launched, is shown in the graph below. Which water balloon went higher? So we're trying to basically, if these are balloons that are being launched up in the air, Things that are launched always follow a parabolic path, which is super cool. And if anyone ends up taking physics in the future, that is something we do. We do projectile motion, which is launching stuff. We make projectile launchers, which is super fun. And we can actually model that data using stuff that we've collected. We can graph the path that our things launch with, that they follow. Which that didn't sound right English-wise, but I think it did. Anyway. So in this one, we can see from our graph, this is the second water balloon. So now, the first one, they gave us the equation. In the second one, they're giving us this graph. So we're basically going to be comparing the maximum height for each of those two things. My graph, super easy to find, because I can see my vertex. Doesn't really matter what the time that it happens at, but that we can see that it has a max height of 120 feet. All right, that's as tall as that second water balloon went. So what we need to do is find the maximum height from the equation, which we should know the vertex is that maximum point. If it's a parabola that opens downward like we have here with a water balloon being launched up in the air, the vertex is going to be the highest point on my graph. So what we need to do is figure out the y value of my vertex for the equation. So looking at that as basically a problem like we just did right above this in box 2. We're going to use the formula to figure out the AOS, plug that number back in to be able to find our y value for the height. So in this case, again, my formula, x equals negative b over 2a. My a value is negative 16. My b value is 80. So I'm definitely going to grab a calculator to do this one, because I'm going to, I can do this first part in my head. Right, negative 80 over negative 32. I could probably do that in my head if I wanted to, but we'll save some time and just do it on our calculator, because I know they both reduce by 8, but then I'm sure it goes further than that. So we end up with 2.5. So 2.5 is my x value. So not the nicest, because I'm dealing with a decimal or a fraction depending on your personal preference, but 2.5 seconds after we launched whatever, the water balloon for the first one, it's reached its peak. So what I need to do now, I'm going to shift to red for this next part. I'm going to plug that in to my original equation to figure out what the height is at 2.5 seconds. So we've got y equals negative 16 times 2.5 squared plus 80 times 2.5 plus 5. So definitely have to use a calculator for this next part. 2.5 squared is 6.25. So negative 16 times 6.25 plus 80 times 2.5 is 200 plus 5. So negative 16 times 6.25 gives us negative 100 plus 200 plus 5. So we get a maximum height of 105 feet. Right, because negative 100 plus 100 plus 200 is 100. Plus 5 is 105. So answering which balloon went higher, we'll do that in green. The second balloon, because the first one that they talk about is the equation. The second one is modeled on the graph. So that would be how we would handle that problem. That is all we got for 8.3 for graphing things in standard form. The homework is on the page there. It's page 436, 437, 4 through 28, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and let me know. Otherwise, have a fantastic day. We'll see you soon.